Welcome to our channel Circuits Analytica. In this video, we will be discussing about bias stabilization. The operating point of a transistor defines the amount of collector to emitter voltage and collector current when no input signal is applied. For the proper functioning of the amplifier, the operating point Q is fixed on the center of the DC load line. Shifting of operating point during the operation of the amplifier leads to malfunctioning of the circuit, leading to distorted output. So the operating point of the amplifier must be stable and it must be fixed on the center of the DC load line. So this is the DC load line. Operating point Q is fixed on the center of the DC load line. For a transistor, collector current IC is given as IC is equal to beta IB plus 1 plus beta into ICBO, where IB is the base current, beta is the common emitter current gain of the transistor, and leakage current through the collector is represented as ICBO. So from the above equation we can infer that collector current IC depends upon leakage current ICBO, common emitter current gain of the transistor beta, and base emitter junction voltage VBE. So when any of the above mentioned parameters vary, collector current also varies, which will shift the operating point or Q point of the amplifier. Now let us discuss what is bias stabilization and stability factor. The process of making the operating point independent of the parameters like beta, ICBO, and VBE is called as bias stabilization. Stability factor is defined as the rate of change of collector current to change in any of the above mentioned three parameters beta, ICBO, and VBE. For any biasing circuit, stability factor is a figure of merit, a parameter which shows its performance. As stability factor of a biasing circuit is dependent on the three parameters ICBO, beta, and VBE, there are three stability factors. S beta, and SV are the three stability factors of a biasing circuit, where S is a measure of stability against leakage current variations. S beta is a measure of stability against variations in common emitter current gain. And SV is a measure of stability against variations in base emitter junction voltage. Stability factor S. Stability factor against variation in leakage current S is defined as the ratio of change in collector current to change in leakage current, considering the other two parameters as constants. So S is equal to dou IC divided by dou ICBO. The other two parameters, beta and VBE, are considered as constants. For a transistor, collector current can be written as IC is equal to beta IB plus 1 plus beta into ICBO. Let us differentiate the above expression with respect to IC with beta as a constant. So we will get 1 is equal to beta dIB by dIC plus 1 plus beta into dICBO by dIC. So rearranging the terms, we will get stability factor S is equal to 1 plus beta, the whole divided by 1 minus beta into dIB by dIC. Stability factor S beta. Stability factor against variation in current gain. S beta is defined as the ratio of change in collector current to change in common emitter current gain, considering the other two parameters, leakage current ICBO and base emitter junction voltage VBE, as constants. So we will get S beta is equal to dou IC divided by dou beta, where the other two parameters ICBO and VBE are considered as constants. So we know that collector current IC is equal to beta IB plus 1 plus beta into ICBO. Differentiate the above expression with respect to IC with ICBO as a constant. So we will get 1 is equal to beta into dIB by dIC plus IB plus ICBO into d beta divided by dIC. Rearranging the terms, we will get S beta is equal to IB plus ICBO, the whole divided by 1 minus beta dIB by dIC. Stability factor SV. Stability factor against variation in base emitter junction voltage SV is defined as the ratio of change in collector current to change in base emitter junction voltage, considering the other two parameters beta and ICBO as constants. SV is equal to dou IC divided by dou VBE, where the other two parameters beta and ICBO are considered as constants. So for each biasing circuit, we have to find the expression for SV, as the expression for base current IB is different for different biasing circuits. Thanks for watching Circuits Analytica. Enjoy learning.